Hi everyone, and welcome to our head demo focusing on DevOps and in particular how we leverage Amazon Web Services for deploying one of our applications. One of the things to note when we leverage Amazon Web Services is the many different ways and architectures we can use. And in this demo, we're going to focus on a very small talk track around the top 4 circles you see here. Infrastructure as a service with Amazon Web Services, so that's how we take a legacy application and basically lift and shift it to Amazon Web Services. Partial app refactoring, full app refactoring using Beanstalk, and then we'll have a discussion around containers and elastic container services as well. One thing to keep in mind, and you may have already seen in the blue-green demo that we also have available, is all of this needs to be kept in the context of cloud operations and cost management as well. If we start off, let's look at our traditional two-tier app that we're going to demo here. So we've created a web application for our fictitious company, Ahead Aviation. Ahead Aviation relies on an internally developed web application for tracking passenger bags. This app can be deployed on your traditional on-premises today, as you see in the slide here, and basically is two-tier system where we've got a web server running on a virtual machine with the OS CentOS 7 and a database server as well, in this case also CentOS 7. If we take that application and move it directly to Amazon Web Services, there's really no difference. The only thing we're doing here is we're deploying Amazon EC2 instances instead of VMware vSphere VMs. We still have operating systems to manage, etc. From the app's perspective, we'll go to our web browser and take a look at it. In our web browser, logged into Amazon, we can see under EC2, we have a number of instances. In this case, we're looking at AHC-ops-516 as one of our particular server names. This is our web server in this case. And what we have here, if we go to the actual app itself, we can see that it's a typical web application. I can type in my name, check in a bag, etc. Look at the status of any bags we've got checked in, and manage our bags as well. Again, it's a very basic application, but connects to a database under the covers to put those bags in the database and retrieve them, etc. Going back to our slides, that app is basically deployed by installing all of the components much like we would in the traditional way. So we've got our operating system running on EC2, but we have to go and install all the various components there. Those can definitely be automated in an infrastructure as a service way using tools like Puppet or Chef. In our case here, we've used Puppet to actually deploy the application, but it's still very manual from the aspect of we have to maintain that entire server, we have to maintain the database server, etc. One of the ways we can advance this is to replace the database server with something like AWS RDS. This is what we call a partial refactor. Some people also refer to it as a cloud-friendly way of deploying the application. We're still going to maintain the web server on the left-hand side, but we've decided we no longer want to manage the EC2 instance for the database server. In this case, we completely rely on Amazon RDS for patching, OS management, etc. All we care about is the data and the data structure. In Amazon, this is as simple as going to the RDS tab and setting up a database there. If we go to Services in Amazon and select RDS, you'll see that we currently have a couple of instances already running. If we select our DB Instances tab, you can see that we have 2 MySQL engines currently running there that we've used for our various demo purposes. The key thing to note though is you can launch a new database instance and you can select from a lot of the favorites that you might use today. Let's say you use Microsoft SQL Servers today, you can basically choose a SQL Server option from Amazon RDS. Again, all we're doing here is saying instead of us managing and maintaining that database service, we're going to offload that responsibility to Amazon themselves, and we'll pay a premium for that, but it takes away a lot of ownership for us. So that's the second way in which we can deploy our application. Well, let's look at one more before we get onto containers. What if we decide we want to have Amazon completely manage all of the services for us? What if we don't want to manage operating systems, we don't want to deal with patching them, etc.? That's not to say we don't have to put them on some kind of patching schedule through Amazon, but let's say we don't want to actually go through that work ourselves. Well, here is taking that same app, refactoring it all in and saying, okay, I'm going to take my, whether it's a Node.js or Python app, and put it into Elastic Beanstalk in Amazon and have it completely managed there. You can see here every service that we've used in the slide is completely managed by Amazon. So Elastic Beanstalk is what we use to deploy the entire application. It takes our code and deploys it onto the underlying instances. Our CloudWatch alarms are all configured so that way all of our alarms, and we can do our login as well through Amazon services. We've also set up the app server into what we call an auto-scaling group. So that means that as the load generates on the app server, it can auto scale out and add additional instances as needed. If we go back to the Amazon console, we can see this in more detail. In our Amazon console now, let's select the Beanstalk service. And what we can see again here is our bag app deployed. We have another demo, which is our blue-green demo, which we encourage you to look at as well, because this shows you how we can deploy the app, make changes, and switch from production to the dev one. This way we can do roll-in updates with low risk, and if something goes wrong, we can immediately roll back. If we select, though, one of the bag apps here, bag app BG dev, I can select the URL, and you can see we have another instance of our bag app running, slightly different version that we've used here, but also running, only this time on Elastic Beanstalk. And again, I can check bags in here. Checking our bag, can list bags, etc. The only difference now is that we're not using the EC2 instances under the covers. Everything is entirely managed by Amazon. The entire application is hosted there. Well, that's great. So that's our same application, just hosted in 3 different ways. You could say this is mostly an infrastructure refactoring effort that we've undergone here. If we want to take this a step further, we can start to also look at application refactoring and starting to leverage other Amazon web services as well. In this case, we've decided to take a containers approach, and we've re-engineered the application using Node.js this time and using containers for scale out. What we've taken is the various elements, so the traveler management, airline management, and particularly what we were looking at earlier was our bag management piece, and we've basically broken that out into separate containers. This allows us to now auto scale up and down the various pieces of the application as needed. In this case, as our bag management service gets utilized, it can scale out the containers for that service by itself. This is opposed to us having to scale out possibly the whole entire web application, spinning up multiple servers, etc. If we look at that in a little more detail, under the covers there's 2 things to think about. Containers are hosted on top of EC2 instances, so we set up auto-scaling groups to ensure that the infrastructure necessary to host the containers is also set up for auto-scaling. Then we basically put our bag management containers, which run on top of those EC2 instances, in their own service auto-scaling groups as well. In this case, we've chosen to use Docker containers on the Elastic Container Service running on Amazon Web Services. If we go and look at that in more detail in the Amazon console, this time we go to the Elastic Container Service under ECS. And what we can see here is we have various ECS clusters. These are Elastic Container Service clusters. I'm going to open up one of the test clusters for a moment, and we can see that we have a test service running underneath here. If we click this one here, we can see that we have a desired count, a pending count, and a running count. And this allows us to basically say, well, how many instances of that particular container do I want to run? If we select update, we can choose the number we wish to run. Set to 3 and update the service. Go back to view our service. And what we'll see in a moment is that the additional services start to run. So additional containers will be spun up, providing the underlying resources are available. Again, the pure beauty of this system, going back to the app itself, is we can re-architect it, and perhaps we want to use other services like the AWS SMS service, the simple email service as well. There are multiple services we can leverage from Amazon, and instead of us having to build these things manually on various servers, we can just have them hosted by Amazon. At this level though, it does require actual recoding elements of your application or breaking out pieces of the application, but it does allow us to make them more efficient and leverage those Amazon services. Great example of this also is serverless architectures like Lambda, etc. that we can help with. Which brings us to the conclusion of this demo. Ultimately, our goal is for you to choose the correct architecture for your application. Some applications, you may be in a hurry to get them out of your data center and just onto Amazon Web Services. That's great. Lift and shift is a great way to quickly move them into Amazon Web Services. But what about if there's some great tips and tricks we can do, some ways to optimize cost, some new monitoring capabilities, things around operations, so we can make sure we manage the whole life cycle of these instances, because as you expand into Amazon Web Services, just like on premises, things are going to grow very, very quickly, and it's important to put a governance, risk, compliance, lifecycle management, operational framework around all of these things. And this is where Ahead can help, and we hope you've enjoyed this demo. Please check out the other ones. Thank you.